Hello everyone, in this video we'll discuss about the storage structure. Storage structure refers to the organization and the method used to storage and manage data in a computer system. It encompasses various levels of data storage ranging from wallet memory used for immediate processing to permanent storage devices for long-term data retention. The storage structure is crucial for efficient data retrieval, integrity, and overall system performance. So this is a diagram of the storage structure. It might be the storage which might be stored in the form of virtual memory or physical memory, and this all data is stored in the form of in the RAM or disk. Okay, the virtual memory is called as the videos or else something, some softwares or else the videos which comes under the virtual memory. And physical memory is the memory which is stored especially in the form of physical memory, and which can be seen, which are directly stored to the RAM or the disk. So these are interconnected with each other. Okay. Difference between the primary and secondary storage. Primary storage, also known as main memory or volatile memory, includes random access memory, which is called as RAM, and cache memory, directly accessible by the CPU, allowing for quick read and write operations. Data is temporarily stored and lost when the power is turned off, essential for running applications and operating systems. Secondary storage, also known as non-volatile or auxiliary storage, includes devices such as hard drives, solid state drives, optical disks, and flash drives. Used for long-term data storage and retains information even when the power is off. Generally has slower access times compared to the primary storage. Provides higher storage capacity at lower cost per unit of storage. So this is the basically the main primary storage and the secondary storage. This is the input device, and this is the output device, and this is the CPU, which is called as the central processing unit, and the control unit, and the arithmetic logic unit. So this is basically the difference between both the secondary and storage thing. Examples: RAM and hard disk. Speed is which is the primary is faster and the secondary is slower. Volatility, data lost when power is off. This data is not lost. Cost per GB is higher, and the cost per GB is lower for the secondary storage. uh, Access type: random access. For the secondary storage, it is called as the sequential and random access. Data transfer rate, which is higher, and the data transfer rate for the secondary storage is lower. Types of storage devices and their characteristics. Hard disk drives, HDD, utilize magnetic storage medium, consist of a spinning disk and read and write heads, offers large storage space or else capacities reaching up to several TB, exhibits relevantly slower access time compared to the SSDs, cost effective for storing a large amount of data. Users case, ideal for desktop computers, servers, and data centers. Solid state drives, based on flash memory technology, which is based on flash memory based technology, contains no moving parts, leading to faster access times and increased durability. Higher cost per GB in comparison to HDDs, available in various form factors such as STA and NVMe. Users case a preferred choice for laptop, desktops, and applications requiring high performance. Optical discs, or which might be CDs, DVDs, and Blu-rays discs. Uh, Laser read storage medium, lower storage capacities, used primarily for media distribution and archival purposes. Slower access time, which with these CDs are used in for media distribution, backups, and archiving. Flash drives. Flash drives is nothing but the USB drives, flash memory based portable storage, compact, removable, and rewritable. Capacities range from a fewer gigabyte to over a terabyte. Slower than SSDs, but more convenient for the portability. Users case data transfer, backups, and portable applications. Network attached storage, NAS, storage device connected to a network, enabling multiple users to access and share data. Can include multiple HDDs or SDDs. Offers features such as data redundancy, backup, and remote access. Requires more complex setup and management compared to direct attached storage. We, this NAS is used in suitable for home networks, small to medium sized business, and enterprises for shared storage solutions. Memory card or SSDs or micro SD cards utilized flash memory technology in small form factors commonly found in mobile devices, cameras, and other portable electronics. Provide a storage for a few GB to several TBs, recognized for the robustness and portability. These SDs or GBs are which are used in cameras, phones, and laptops, and so on devices. Cloud storage. Storage provides over the internet by third-party service, accessible for any from anywhere with an internet connection. Scalable and often pays as you go for the pricing. Relevant, and internet connectivity and subject to provider security policies. Which is used for off-site backup and data sharing and collaborations. Microprogramming. The programming is nothing but is a technique for implementing the control logic of a computer central programming unit using a sequence of micro constraints stored in a special memory called the control store. This micro constructions define the low level operations needed to execute machine level instructions. Role of the microprogramming in computer architecture is microprogramming act as an intermediary between the high level instruction set architecture and the physical hardware of the CPU. It simplifies the design of the control unit by breaking down complex instructions into a several simple steps, each definition by the micro construction. This technique allows for easier implementation, modification, debugging of the control logic, as change can be made be microcode without altering the hardware. How microprogramming controls the execution of the instructions. The instruction fetch. The CPU fetches a machine level instruction from memory and place it in the instruction register. Instruction decode. The instruction decode encrypts the machine level instruction and identifies the corresponding sequence of micro instructions in the store control store. Micro construction execution. The control unit reads the first micro construction from the control store. This micro construction specifies the low level operation needs to execute part of the machine level instruction. Each construction typically includes field that control various parts of the CPU, such as register, transfer operation, arithmetic or logical operations, and memory access as well. The control unit executes the microconstructions, which might involve moving data between register, performing an ALU operation or an access memory. Microconstruction sequence. The control unit determines the next microconstruction to execute based on the current microconstructions sequence field. This could involve proceed to next sequential microconstruction, branching to a different microconstruction based on the condition. Example, a result of the ALU operation. Completion. The sequence of the microconstruction continues until the entire machine level instruction is executed. The control unit then fetches the next machine level instruction, repeat the process. So this comes under how the microprogramming controls the execution of the instructions. Advantages and the disadvantages of the microprogramming. The flexibility of development, cost, debugging, compatibility, adaptability, or instruction and set complexity and reliability are comes under some of the advantages and disadvantages of the microprogramming. So flexibility easier to modify and which is very complex to modify. Development specifies slower execution compared. Cost can be reduced. Hardware cost by simplifying control unit design. Requires additional memory for the control. Debugging easier to debug and test. Microcode errors can be default to trace. Compatibility allows for easier implementation of instruction. May not achieve a maximum possible performances. Adaptability can be adapted to different functions and architectures, limited by the speed of the control memory. Instruction set complexity can handle complex instruction set efficiency. Increased control memory size can lead to higher cost. Reliability generally more reliable due to simple hardware. Performance can be hindered by slower micro construction execution. So in this video we have gone through for different set of topics like the storage structures and structures and the difference between the primary storage and the secondary storage, and the role of the primary storage as well as the microprogramming uh, its various advantages and its disadvantages. So thank you so much. In the upcoming video we'll learn about the different storage hierarchies as well. Thank you so much.